And before we start to do it, I just want to explain a little bit about the data collection. As we explained before, the main purpose of data collection can be to describe the data, by simple descriptive methods, or usually we use to use the data to compare two different or more than two different groups by estimations or by testing hypotheses in different ways, depend on the methodology that we had for data collection and research question. When we want to compare groups, we should know that are we going to compare it groups for a continuous variable or for a categorical variable. And then if this categorical, if it's we are comparing just two groups, or we comparing more than two groups. Of course, we can have comparison for one group of observation, compare the mean with the specific value. But more often we are doing two groups that these two groups can be two independent groups, or it can be a paired observation. When we say two independent groups, we mean two groups that totally different. Maybe they are different in sample size, so they are different in other descriptive variables. But when we say paired observation, we are talking about a group of people which is tested two different times, and then we compare before and after, for example, for the same group of people. As an example, we use two independent groups, and we can use parametric or non-parametric methods for analysis of the data here. It depends. We use parametric method if these two groups have approximately normal distribution, and because it's not exact normal distribution, it's also called t-distribution, to remember that the test that we are going to use later called t-test. And also the standard deviation in these two groups should be similar to be able to use parametric methods. And also we can use two sample t-tests because this is two different sample. We also have another t-test called paired, which is used if the two groups are the same people in two different times. And if none of those criteria is available there, then we cannot use parametric. Then we go to use non-parametric methods, which in this case called Mann-Whitney test, that we will explain later in another lecture. So imagine we want to do the t-test, and we want to compare the mean score of a continuous variable like here, for example, body fat percentile for groups of people, which is here is male and female. To be able to answer this question and compare groups of male and female when doing the t-test, we go to the SPSS and we have the data here, and then we go to the analyze, and then in descriptive statistics, in compare means, this one, in compare means we are going to choose the independent sample t-test. And here in the new window we are going to find the variable that we want to test, in this case, for example, fat percent, and then put it in the test variables. Of course, it's just something fictional right now, because if we want to check the fat percentile between male and female, they have different distribution, and maybe it's not a wise thing to do it for in reality, but just as a test we are doing it here. And then we need to do the grouping variable here. We can use the shown here, and then put it here. Here, as you see, you have two question marks because we should define the groups. And as you remember, we had the group 1 and category 1 and category 2 for male and female. So if we define the group, we put group 1 is 1 and group 2 is 2 and we have no cut point, so just continue. And now we are ready to do the t-test for those. And okay. So the next result will be appear here in the output. And as you see, the first thing that we have here is group statistic. We have the genders here, and we have the number of the people in each group, 48, 109. As you see, they are different, and also different means. And here we have a standard deviation that we are going to see how different they are. But we cannot do it at this, and SPSS just already did for us. SPSS has a part here in the second table. I just put it a little bit here. As you see, this part, it says Levin's test for equality of variances. It wants to are those variances are equal or not. And we have a value here, which is it's 0.016. And when this value is less than 0.05, which is here less than 0.05, we should look at the second row. If this value was more than 0.005, we supposed to read just the first row here to check the result. Anyway, what we see here is about the this column, about the significant two-tailed, to see if it's significant or not. So because this is less than 0.05, we are looking here. In this case, they both are the same, but this is the rule. We are looking here, and as you see, this is significant. So what does it mean? It means that the two groups that we have here are significantly different for the distribution of the fat distribution between male and female. They are significantly different. This is what we expected actually.